All right, kids, we're looking at the disk method this lesson, and it's going to be revolved. The last lesson you were revolving it around the x and y axis. This is now going to be revolved around other axes, like a straight line, a vertical line like x equals 1, or a horizontal line like y equals 2. We're going to be revolving around those. So the picture is going to be a little bit different for these. But if you have the handle of what I've been talking about with that representative rectangle, it's going to make these relatively easy. So recall the volume of a solid. Remember, you're rotating around and it creates a disk type figure, which is a circle. And so really what you're doing to find the volume is taking the integral of the area, pi r squared, with respect to x. And to get the r in these, all you need to do is take f of x minus g of x, the top of your representative rectangle minus the bottom of your representative rectangle. If it's revolving around the y-axis or some line like x, another vertical line like x equals 1, then you're going to do right minus left instead of top minus bottom. So one of the big things that you want to remember in this section and in all these sections with finding areas and volumes is that as you're doing this, the representative rectangle is perpendicular. It has to be perpendicular to what you're revolving around. So to the axis of revolution. And I'm sure you've seen this in the other videos. So that representative rectangle has to be perpendicular to whatever you're revolving around. So if you're revolving around the x-axis, then it's going to be vertical. If you're revolving around the y-axis, it's going to be horizontal. And again, I think we've talked about that previously. So the other comment I have to make is the curriculum videos for these sections, the next couple, they tend to be, I watched them and he shows a couple different ways to do these. I believe that his method's a little bit more complicated than this method of these representative rectangles. So whatever, I mean, you can choose to watch whichever way you want to watch. But I think that this way tends to be easier because it's consistent no matter what you're revolving around, or in the next couple sections you're going to see when there's a hole in the middle of the disk. It's called the washer method. What happens with that? So the rectangles seem to be the easiest way to go. Let me show you. Find the volume of the solid form revolving the bounded region about the given line. Set up the integral but don't evaluate. So we don't have to actually come up with an answer for these. We just are going to set up the integral. You have to see the picture first. So the picture for most of these functions that we're going to be working with are things that you can probably just draw from hand. You don't need a calculator to do it. For example, this guy, you can tell he's an unhappy parabola, but he's moved up 3. So he is up 3 and unhappy. There he is. This time you want to revolve it around the line y equals 2. Well, y equals 2 is right here, right? This is y equals 2. So what's the area they're talking about? It's the part that's bounded by y equals 2 and my parabola, which is the peak of this thing. And what happens with this one is when I revolve it around that line, it's going to come down kind of like this. Now that part doesn't matter, it's just kind of a visual for you. It's not going to play any part in our setup for this. So if I'm revolving around the line y equals 2, that's kind of like the x-axis, it's a horizontal line. So that means that my representative rectangle has to be perpendicular to it. So my representative rectangle, hopefully you can see it, is that guy right there. Perpendicular to y equals 2, which I'm revolving around. Okay, so a couple things we need to be able to set up the integral. First thing we need to know is, what are these points of intersection? What are they? So I'm going to set these functions equal to one another. 3 minus x squared equals 2. If I flippy-floppy, x squared equals 1. X is plus or minus 1. Does that make sense in the picture? Absolutely. So this coordinate here would be the coordinate 1, 2. Remember, my line for y is y equals 2. And this coordinate over here is negative 1, 2. So I need my bounds. And the second thing that I need is what the area would be, right? Because for me to be able to find the volume, I have to integrate the area. So my area is pi times r squared. Well, here's where your rectangle comes into play. What does the top of the rectangle hit? And you say the parabola. And I say, yep, 3 minus x squared. And then where does the bottom of the rectangle hit? And you say the line y equals 2. So I need minus 2, top minus bottom, quantity squared, right? Pi r squared. This is my radius, f of x minus g of x, top minus bottom. All right, what can I do with this? Can I make it any better before I integrate? Sure. This is a perfectly valid answer, by the way. You can put this into your volume thing and it would be perfectly fine with Mr. AP. But really 3 minus 2 is 1, so I can make this a little bit nicer and call this 1 minus x squared squared. And then put that into my volume. Volume is the integral from negative 1 to 1, my bounds, of pi, my area, times 1 minus x squared squared with respect to x. And that's my final answer. All right, so now they're saying, okay, take this next one. Take 2 minus y squared, x equals 1, and revolve it around x equals 1. So let's take a look at what this one, when it's a y squared deal, and you can plug points in to see this, but it's going to be a sideways parabola. So here's how this guy looks. You can plot some points if you need to, but he is going to go this way. He's my x equals 2 minus y squared. And then I'm revolving it around the line x equals 1. Well, x equals 1 we're going to say is right about here. And again, you just need a general picture. It doesn't have to be perfect. You just need to see how your rectangle is going to go. So I'm talking about this peak again. If I were to revolve it, it kind of looks like this. And again, you don't necessarily need to see that, but that's where it goes. Couple things I need to know points of intersection. Now this time I need to know what the y coordinates are, right? Because I'm revolving it around a vertical line, which is like the vertical of the y-axis. So this time, actually, my representative rectangle is going to be horizontal, perpendicular to what I'm revolving around, which is x equals 1. And I need to know these bounds in the y, what the y values would be. So I'm going to take 2 minus y squared, set it equal to 1, and I'm going to solve it out. Again, I'm going to flippy floppy, so I have a positive y squared, and when I do that I get 1. So y is plus or minus 1. Does that make sense? Yep, 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 yep. This would be 1, negative 1. This guy up here would be 1, 1. All right, got the bounds. Are my equations solved for x? And I say, oh, yeah, look at that. Sweet, I don't have to do that. It's a step I don't have to take. So let's take the area and figure that out, pi r squared. What's r? R is right minus left. What does the right hit? 2 minus y squared. Minus. Now you can put that in parentheses if you want. What's the left side hit? It hits 1. Right, this vertical line, x equals 1, and that's being squared. Pi r squared. So I can put my volume together. I'm going to simplify this as I do the volume formula so I don't have to write it twice. My integral goes from negative 1 to 1, my y values, negative 1 to 1, of pi. 2 minus 1 is 1, 1 minus y squared squared dy, and I am done. That's it. Again, I really, really, really believe that these representative rectangles set it up perfectly for you. It's just a top minus bottom or a right minus left, and it makes the problem so much easier than some of the things that he was showing you on the video. All right, last one that's in on the examples. This one is 2 to the x minus 3, y equals negative 2, x equals 3, but I'm revolving it around. There's a winter word wall thing. revolving it around the line y equals -2. So again, what does this look like? Where am I with this thing? So if I look at this guy, I am an exponential function moved down 3. Okay, so you don't need, you can make a table of values if you want, but if you just think of the generics of this thing, you know you have 2 to the x. Well, that's exponential. It's something that's growing, but it's moved down 3. So 1, 2, 3. Normally, exponential functions, they have a horizontal asymptote on the y-axis. I'm sorry, on the x-axis. So this time, if I'm moving down 3, my horizontal asymptote is down here. So it's going to skate along that and then go up. Exponential function moved down 3. This coordinate here is at 1 above the x-axis, just like it would be if this were just a 2 to the x. If x is 0, then you have y equaling 1. So it's always a coordinate that's 1 above whatever that horizontal asymptote is for these. All right, what else do we have? We have y equals -2. Well, -2 is down here. Right, y equals -2. Oh, no, -2 is where my dot was. My bad. Hang on a minute. Let me fix that. Remember, that was moved down 3. Okay. Whew, there it is. And x equals 3. Well, x equals 3 is over here. So what's the part bounded by that? This is x equals 3. This is y equals -2. And then I've got my function here that is y equals 2 to the x minus 3. So the part that's bounded by those 3 sections is this part right in here. So I color that in. Pretty. What am I revolving around? I'm revolving it around the line y equals -2. Well, -2 is here. Perpendicular representative rectangle is going like this. If I were to revolve that just for kicks and giggles, it comes down this way like this. It's going to be revolved around that line. What are my bounds? Well, I know that I need x values, right? So because I'm revolving it around a line that is horizontal, so I need the x values. So I know this guy here, he would be 0, -2, right? And this guy here I actually know too without having to solve anything, because my x value is 3 and my y value is -2. So I have my bounds and I'm ready to set up my area. My area is going to be pi r squared. What's r? Top of my representative rectangle hits the exponential function. So it's going to be 2 to the x minus 3. The bottom of my representative rectangle hits -2. So minus a -2. And that's going to be squared. So as I put this together, I'm just going to put it right in the volume. I'll simplify as I get there. It's the integral from 0 to 3, my x values of my bounds. And my function is 2 to the x. -3 plus 2 is -1. Quantity squared, what did I forget? I forgot Mr. Pi. There it is. That's it. So I firmly believe that using these representative rectangles makes it so much easier, because it definitely defines what's on top and what's on the bottom, or what's on the right and what's on the left. So we're going to do just a couple example problems and then we'll call it a day for this section. First one I want to look at is number 5. Number 5. Directions say set up the integral that gives the volume for the solid form revolving the bounded region about the given line. Set up the integral but don't evaluate, so we don't have to give a final answer for these guys. So number 5. I'm in the first quadrant. I'm the sine graph. And let's do that first. Sine graph. Sine graph goes like this. Keeps going. We're going to just stop there. First quadrant. y equals 0, well that's the x-axis, and x equals pi over 2. Now think about how the sine graph goes, right? This is 0, and then it goes, if I think about what this is over here when it crosses again, hopefully you remember that that's pi, which means that pi over 2 would be at the peak. Right there. This is pi over 2. So the section we're looking at for this one is this section right in here. And I'm revolving it, funny enough, right around the line pi over 2. So if that's the case, when I revolve it, then it's coming over this way. I already have it drawn. Now, if I'm revolving around a vertical line, remember my representative rectangle has to be perpendicular to it. So my representative rectangle is this way, in that shaded region. Which means that I need my my y values, right? Because I'm revolving around a vertical line just like the y-axis. It's going right to left, and I need to know what this y value is up here and what the bottom y value is down here. So we know that this guy's 0, 0. That's not a big deal. What is the sine at pi over 2? And you can probably remember too that what's the tallest that the sine graph goes to, and that would be 1. So when x is pi over 2, y is 1, and that's going to give me my bounds. So we got that set. The other thing that I need to do, and this is why I picked this problem, is I need to solve for x, right? This has to be in terms of y is my integral, which means I have to solve for x. And I think I showed you this in one previous video, but if I want to undo this to get to the x, I have to inverse sine it. So x is going to equal sine to the negative 1 of y. And that's it. You just need to remember that rule that you're doing the inverse to be able to get to that x. And then I think you're ready for the area. So my area is going to be pi r squared. Right minus left. Right is pi over 2 minus, see the right hand side here, and the left is my function. My function is sine to the negative 1 of y, quantity squared. All right, so let's put that in our volume. My bounds are the y's, 0 to 1. My area is pi over 2 minus sine to the negative 1 of y, quantity squared dy. Are there other forms you could put this as? You could multiply the pi through. Sure, there's other ways you could write it. But really the final answer is, and again, you know how that works on like a multiple choice question. They could give you all sorts of different equivalent forms to this. But this is basically the answer. All right, next one I want to do is 7. This one's revolving around the line y equals negative 2. I have a parabola, move down 3, and let's see what this guy's going to look like. X squared minus 3, 1, 2, 3, happy parabola. Y equals negative 2, that's down here. And I guess that's all I need because I'm revolving around the line y equals negative 2. So I'm taking this little peak, I guess I should say it's a valley, right? That little piece, and I'm going to revolve it around this line, so it's going to come like this. Representative rectangle has to be perpendicular. You're going to get tired of me hearing that, saying that, at negative 2. So that means it's going this way, perpendicular to it. I need to know my bounds. I need to know this point and this point. How do you get them? By setting the equations equal to one another. X squared minus 3 equals negative 2. Swing the 3 over. We are getting a whole lot of 1s and negative 1s, aren't we? Plus or minus 1. All right, so I know what my x values are. This one would be a negative 1, negative 2. This one will be a positive 1, negative 2. And I'm ready for my area. Area is pi r squared. What's r? Top minus bottom. Well, the top hits negative 2 minus the bottom, which is the parabola. X squared minus 3. Watch your parentheses with this, right? You want to make sure that you've got the parentheses going on. Now I can clean this up as I put the volume together so I don't have to write it twice. I have the integral going from -1 to 1, and I am pi. And then I have -2, but this is a -3, so that's +3, gives me a 1, minus x squared, or I'm sorry, x squared, not pi squared. X squared, squared, dx. Okay, that's it for those kind. I've got, I think that's it. That's it. I thought there was another page to this. This one's a short one. Okay, you got the idea. Just rock those representative rectangles, and if you have questions as you're going, shoot me an email, or I'll see you in class.